Okay, so today we're going to talk about 4.3 solving systems of linear equations, and this is going to be by elimination. Another method that we know this by is addition, and we'll talk about why here in a bit. Okay, so this is the third method. This method is easiest when we're in standard form. Okay, so if you look at example A, 3x plus 2y equals 2, and 4x minus 2y equals negative 16. Both those equations are in standard form. So if we were to do substitution, like what we talked about last class, then when we solve for one of our variables, we're going to get fractions, which usually make it more difficult. So what we want to look for is there a variable that both equations have the same coefficient, just with opposite signs? So if we look at our x's, okay, we have 3x and 4x. Okay, those aren't the same. They don't have opposite signs, so that doesn't help us. Okay, 2y and negative 2y. Okay, those are the same coefficient, 2, and one's a positive, one's a negative. So that's what we want. So if we add these together, which is why this is sometimes called the addition method, 3x plus 4x is 7x. 2y plus negative 2y cancel, equals 2 plus negative 16 is negative 14. And to get x by itself, we're going to divide by 7. So x equals negative 2. Now we want to plug in, solve for y, because remember our solutions are always ordered pairs. And it doesn't matter which equation you plug into. I'm going to just plug into our first equation. So we have 3 times negative 2 plus 2y equals 2. 3 times negative 2 is negative 6 plus 2y equals 2. Add 6 to both sides. So 2y equals 2 plus 6 is 8. Divide both sides by 2. So y equals 4. Remember, we always write our solutions as ordered pairs. So negative 2, 4. All right, now let's look at B. So B is a little different. Okay, if we look at our x's, okay, we have 1x and 2x. So those don't have the same coefficient. If we look at our y's, we have 2y and negative 5y. So one is a positive and one is a negative, but they're not the same number. Okay. So when this happens, we need to figure out something to multiply. So it depends, do you want to get rid of your x's or do you want to eliminate your y's? This is total preference. On this one, let's go ahead and eliminate our x's. Oops. Okay, so since we want to eliminate our x's, we want to find a number that we can multiply. So that way our equations will be able to cancel. So since we already have a 2x here, let's multiply the first equation by negative 2. Okay, if we do that, our new equation is negative 2x minus 4y equals negative 8, because we're distributing that negative 2 to everything in that equation. On our second equation, we're just going to leave it the way it is. So 2x minus 5y equals negative 1. And now we can add, because we have a negative 2x and a positive 2x. When we add those, our x's are going to eliminate. Negative 4y plus negative 5y is a negative 9y. Negative 8 plus negative 1 is negative 9. Divide both sides by negative 9. And we get y equals 1. Okay, so now we want to plug back in and solve for x. Again, it doesn't matter which equation we plug into. I'm just going to use the first one. So we have x plus 2 times our value for y, which we found to be 1, equals 4. 2 times 1 is 2. And to get x by itself, we're going to subtract 2 on both sides. So x equals 2. So our ordered pair, 2, 1. All right. Looking at A and B, determine which method is best to solve the system of solutions. That's all. We're going to talk about these tomorrow as a class, but I want you to look at them and decide, would you use substitution, elimination, or would you even use graphing? Okay, so I want you to decide which one would you do. Okay, and then we'll go through that tomorrow. All right, let's look at this application problem. Sorry for this 4.2 quiz review. I thought I deleted that. Okay, so a florist is making bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. Each mini bouquet has 3 roses and 5 peonies, and each regular bouquet has 5 roses and 11 peonies. How many of each type of bouquet can the florist make? So we're looking for how many of each type of bouquet. So that means that our X is going to equal our bouquets. And let's let Y equal our mini bouquets. Okay, and our 2 equations are going to be based off of the flower. So our first equation is going to be about our roses. Okay, so for our regular size bouquets, we know we have 5 roses. So we're going to say 5x plus we have for our regular bouquet, or sorry, for our mini bouquets, we're going to have 3 roses. So 3y equals the total number of roses is 118. Okay. Now looking at our peonies. Okay, our regular bouquet has 11. Plus our mini has 5. For a total of 226. Okay. So now we need to, if you notice, none of our coefficients are the same. So we need to figure out a way to multiply. So what we're going to do is easiest way to think about it is swapping your numbers. So let's get rid of our y's this time. Okay. So if we eliminate our y's, 3 and 5, the least common multiple is 15. So I'm going to multiply this top equation by 5. And if we do that, we get 5 times 5 is 25x plus 5 times 3 is 15y equals 118 times 5, 590. Okay. So now in our second equation, we want to get 15 again. So we're going to multiply by 3, but we already have a positive. So let's multiply by negative 3. Okay, so 11x times negative 3 is a negative 33x. And then 5 times negative 3 is a negative 15y. And 226 times negative 3 is negative 678. Okay, and now we're going to add our 2 equations together. So 25x plus negative 33x gives us negative 8x. 15y plus negative 15y cancels. And 590 plus negative 678 is negative 88. Divide by negative 8. And x equals 11. Okay. So now we're going to plug back in to one of our equations to solve for y. So I'm just going to use our our first one. So we have 5 times 11 plus 3 times y equals 118. 5 times 11 is 55 plus 3y equals 118. Subtract 55 on both sides. So 3y equals 63. divide both sides by 3, and y equals 21. So we know now that there are 11 regular bouquets and 21 mini bouquets.